Okay, I'm going to work out a makeshift test review for y'all. I am not going to be at school on the day of the test because I have a funeral to attend, and since I won't be there, I thought maybe I could do this to maybe ease a little bit of anxiety. What this is basically going to be is a carbon copy of the test, except the test will have different problems. And so you'll kind of see what's coming, how long it should take, what kind of problems you'll see. Also, I have both of my daughters in my room with me, and they are watching Bambi and making a mess. So if you hear things in the background, it could very well be either Bambi or my daughter's playing. So um, let's get started. The first problems are going to be like this, where you're supposed to graph, and I forgot to put in the grid, so hang on just a second. There we go. And so the first few problems, there's going to be 3 or 4 problems where I give you the equation in standard form, like here's number 1, here's the second one, and I'll give you the equation in standard form. And on the graph paper, I also will go ahead and adjust the axes for you so you'll know about where the graph needs to be. So this one, number 1, first thing I'm going to do is identify that this is a parabola, P-A-R-A-B-O-L-A. And with a parabola, I start by finding the vertex. This vertex is going to be -1, 3. Negative, you change the signs, and with the x is +1, so -1, and y -3 means the y coordinate is going to be 3. And also, I'm going to give you this entire list, and you have to decide which ones to answer. So I'm actually going to go ahead and mark the ones I'll answer because this is a parabola. A parabola does have a vertex. A parabola does have a focus. It does have a directrix. It does have an axis of symmetry. It does not have a major minor axis transverse conjugate. It does not have asymptotes. It does have a latus rectum, radius for a circle, and a parabola does not have a center either. So we're going to answer these 5 things for the parabola. I will find my p. Remember, this number right here is actually 4p. So 4p equals -4, which means p is -1. And remember, p tells you how far you go to get to the vertex, or to the focus and the directrix. So I'm going to start by plotting my vertex, -1, 3. And then the next thing, since my y is squared, I know this one's going to open left or right, since the y is squared. And since p is a negative number that's less than 0, therefore this one's going to open left. So I know this parabola, the general shape of it, is going to be going this way. Now I'm going to come back and erase that and adjust that later. So let's see. P is 1, or -1. That means I will go 1 distance to get to my focus, 1 unit. So my focus is going to be right here, and that ordered pair was -2, 3. So my focus is -2, 3. My directrix is a line that's on the opposite side of the vertex, and it's 1 unit away. So my directrix is going to be this line right here. It's a vertical line that goes through x equals 0. And so my directrix equation is x equals 0. We just went 1 unit to the right because that's what p was. Axis of symmetry is the line that goes through the vertex right here. That is a horizontal line, and horizontal lines are y equals something, and that goes through a y coordinate of 3. So my axis of symmetry is y equals 3. And then the last thing is the latus rectum. And the latus rectum is, if you remember, from the focus, you go 2p on each side, and that tells you how wide the parabola is. So at this point, I'm going to get rid of this. Uh-oh, Molly's about to start playing with the... Molly, quit playing with the mouse. No, leave that alone. Leave that alone. Okay. Okay, so my latus rectum, if from the vertex, from the focus, right here's my focus, from the focus, you go 2p in each direction. So p is 1, so I'm going to go up 2. I'll go down 2. That tells me the width of my parabola. Molly, let go of that. Hey, let go. Okay. That's the width of my parabola. And then I can get a really accurate graph of the parabola because I know it goes through this vertex, and it's, whoa, that was really bad. We'll pretend that didn't happen. It's this wide. It looks something like this. Oh no, Molly, what are you doing? What just happened? There we go. Molly, get your sticky fingers off here. This is going to be a long video because I'm going to have to play with my kids the whole time. All right, so there is the parabola, and the latus rectum is the width across the focus, and that is a width of 4 units. So my latus rectum is 4. So there we go. That's the parabola. Okay, so there is the parabola. let's keep moving. Oh, Molly, I thought I had you distracted. Okay. This one, here's the standard form. It is a fraction plus a fraction. Both things are squared. This is going to be an ellipse. And with an ellipse, I'm going to go ahead and mark the things I'll answer. So let me get my highlighter. An ellipse does have a center. It does have vertices. It does have a focus. It does not have a directrix or axis of symmetry. It has major and minor axes. And it does not have any of the rest of these things. Or at least we're not going to answer. Some of you random people on the internet may realize, say, hey, ellipse does have a directrix, but we're not going to answer it in my class. So there you go, because I'm a lousy teacher. Take that, Math League of America. All right. I will start by finding the center of my ellipse. Since it is only x squared, there's not a number in there with the x. The x coordinate is 0. Y minus 3 means my center is going to be 0, 3. And I'll go ahead and plot my center, 0, 3. And then I'm going to find my a and my b. Under the x is 16. Square root of 16 is 4. That's my a. Under the y is 4. And the square root of 4 is 2. That's going to be b. And those numbers, A and B, tell you how far up, down, and left and right. Under my X is 4. My X-axis runs left and right, so that tells me I'm going to go left 2, 3, 4, and I will go right 2, 3, 4. Under my Y is 2. That's the number under Y, and my Y-axis goes up and down. So in the up and down direction from my center, I'll go 2 units, and I will go 2 units, and that is going to be enough to graph my ellipse. So my ellipse is going to come somewhere like that. Then I'll answer the rest of my questions. My vertices, I like to answer it this way because I'm kind of lazy. I started at an x coordinate of 0, and then I went right 4 units, and I went left 4 units. So I'm going to add and subtract 4 from 0, and I did not go up or down. And then my other 2 vertices, I went up and down 2 units. Well, up and down changes the y coordinate, so up and down 2. Or you could simply write them as 4 different ordered pairs. We have 0, 1, 3, 4, 0, 5, and negative 4, 3. You could do that as well. The focus, or the foci, we're going to need to find c. And with an ellipse, a squared minus b squared is c squared. So I'll plug that in. A is 4. 4 squared is 16. B squared is 4 equals c squared. 12 equals c squared, which means the square root of 12 equals c. And I'm not going to bother simplifying that. I think simplifying some things is kind of silly. So square root of 12 is going to be how I get to my foci. And the foci go on the long axis. That's our major axis. So I'm going to go left, and I'll go right with square root of 12. Now, square root of 12, you will have a calculator, so you could punch that in. That's going to be somewhere in the vicinity of 3 point, I don't know, I'm just guessing 3.4-ish. I don't know, something like that. So I know I'm going to go left 2, 3, and a little bit more. And I'll go right 2, 3, and a little bit more. And if you go left and right, that changes the x coordinate. So 0 plus and minus, and I went the square root of 12. And my y coordinate stayed at 3. Then we have major and minor axis. The major axis is the long distance. If we went left and right 4 units, that's 2 distances of 4, which is 8. And I went up and down 2 units, so that's 2 distances of 2, which is 4. And that's everything we're going to do for the ellipse. Good? Good? All right, let's see. Next one, fraction minus fraction. Both of them are squared. This is a hyperbola. And with a hyperbola, let's see what all we're going to find for the hyperbola. Highlighter. Let's go. A hyperbola does have a center, has a vertex, has foci, has, no, it does not have a directrix. We're not going to find the directrix. No axis, it has transverse axis, conjugate axis, and asymptotes. So we're going to find those 6 things for the hyperbola, starting with the center. Now, remember, the number with x is negative 3. That means this x coordinate of my center will be 3. Y plus 5 means the y coordinate is negative 5. So I'm going to start by plotting the point 3, 1, 2, 3, 4, 5 down. There's the center for this hyperbola. Then I'll find my a and my b. The a is always first in a hyperbola, so the square root of 9, which is 3, that's my a. The square root of 25, which is 5, that's my b. And those numbers, just like the ellipse, they tell you how far up and down and left and right. My y-axis goes up and down, so the number under my y coordinate here, y plus 5 That's a 3 squared. So I'm going to go up and down 3. So I'll go up 3, I'll go down 3. Under my x, that's a left and right distance. Under x is a 5. So I'm going to go right 2, 3, 4, 5. And I'll go left 2, 3, 4, 5. And those 4 points give you what I call the magic box. So let's draw the magic box through those 4 points. And then the asymptotes go through the corners of that box. So I'm going to draw an asymptote going this way from the center through each corner. Asymptote going that way. Asymptote going this way. Asymptote going this way. Then to draw my hyperbola, since my y-coordinate is first, this hyperbola is going to go up and down. My y-axis goes up and down, so since y is first, this hyperbola is going to go up and down. So I graph this hyperbola, I follow the asymptote, and then I need to hit this point right there. That's a vertex. And then we'll follow the asymptote going out the other way. So there's the top part of it. Same thing down here. I need to hit that point because it's a vertex. Follow the asymptote, hit the point, follow the asymptote going back down. Good. So there's the graph. Now we're going to use that to find everything else. My vertices, I went up and down 3 units from the center. If you go up and down, that changes the y-coordinate. So from -5, I went up 3, and I went down 3, plus and minus 3. The foci, we're going to need c. Now with the hyperbola, it's a squared plus b squared equals c squared. So we'll see a squared is 9, b squared is 25. 9 plus 25 is 34. And c is the square root of 34, which is pretty close to 6. And since this is going up and down, I'm going to go up and down to get to my foci. So I'll go up pretty close to 6. I'm going to go down 3, 4, 5, and almost to 6. 6 squared is 36. So I know this is just less than 6. I'll say it's about 5.8. That's a guess. And so if I go up and down, that changes the y-coordinate. So my x stayed 3. I went up square root of 34, and I went down square root of 34 from my y-coordinate of -5. Good? Good. Transverse axis, that's the distance between vertices. And that distance, you can count that as 6. And the conjugate axis is the other dimension of the box. I went left 5 and I went right 5. That's 2 distances of 5, which is 10. And then the asymptotes, I use point slope form. Both asymptotes go through the center, so I know the point is 3, -5. And then the, I think Bambi's mom's about to get shot. Run! Run! Ah, every time. She's going to make it one of these days. I swear she will. Anyway, okay, so I have my point. Then the slope is going to be from my center to a corner of my box, up 3 over 5. So that's a slope of 3/5. But we also have a negative slope of 3/5 as well. So plus or minus 3/5 is the slope. And then I'll throw it in point slope form. Y minus a -5 is y plus 5 equals the slope of positive or negative 3/5 and a x coordinate of 3. So x minus 3. There we go. Good, good. Good, 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 good. All right, and then there was one more graph out of standard form. Now this one, you could treat this like an ellipse, but this is actually a circle. And circles are the easiest ones. This is a circle with a center of -1, -2. So I'll put that at the center, -1, -2. I don't know why I wrote, a circle, yeah. And then this number right here is the radius squared. So if that's the radius squared, that means the radius is actually the square root of 36, which is 6. And that's really all you find for the circle, the center, the radius, and then we'll graph it. So my center was -1, -2. And then I will go 6 units in all 4 directions to graph. So, let's see, the Bluetooth thing quit working. Why isn't this working? There we go. All right, so I'll go right, 2, 3, 4, 5, 6. Uh-oh. Jeez, what's going on here? Um, Holy cow. Hang on. Let's put that back where it was. There. All right. Now, finally, right, 2, 3, 4, 5, 6. Up, 2, 3, 4, 5, 6. Left, 2, 3, 4, 5, 6. And then down, 2, 3, 4, 5, 6. And then we'll graph that circle. Now, I have cool little drawing tools here, so my circle's going to be pretty darn sexy. Y'all's may be kind of ugly, so make sure you put big points that you're trying to hit, just in case you miss them or your circle gets kind of lopsided. I can tell what you at least tried to do. So there's the graphing part, and like I said, I'm going to center the axes for you, or put the axes in a position so that you know where the graph should go. If you end up, say, on this hyperbola, if your center doesn't fit, then that means you've got the wrong center. I'm going to fix this so that the shape should fit nicely onto the grid provided. So there's the graphing. I'm actually going to cut this up into different videos, and the next video is going to be putting equations into standard form.